In question 8a, we're asked to differentiate the function from first principles. In the first instance, we set up our graphical representation with our first coordinate of x, 7x squared plus 5x minus 2. We move this small distance delta x across the x-axis to generate our new x-coordinate of x plus delta x, and our second y-coordinate, which is simply a substitution of x with x plus delta x. We then treat this section of the curve as if it was a straight line, in fact a right angled triangle, and then we can obviously write the gradient as being the change in y over change in x, delta y over delta x. Change in y will be 7x plus delta x squared plus 5x plus delta x minus 2 subtract 7x squared plus 5x minus 2 all over our change in x, which we set as being delta x. The next stage is to expand our numerator out, which gives us 7x squared plus 14x delta x plus 7 delta x squared plus 5x plus 5 delta x minus 2 minus 7x squared minus 5x plus 2 all over delta x. As always, the numerator looks quite tricky, but immediately we see the 7x squareds cancel, the 5x's cancel, and the 2's cancel. We can then rewrite this as being delta y by delta x is 14x delta x plus 7 delta x squared plus 5 delta x, all divided by delta x. We should see at this stage that every term has delta x in it, so we can divide through by delta x, giving us delta y by delta x is equal to 14x plus 7 delta x plus 5. We then can say, well, this delta x distance was a generic distance that we could actually pull back so that it was almost approaching 0, which means our function will therefore become 14x plus 5, because obviously the delta x part of this expression will become insignificant, giving dy by dx being 14x plus 5.